Welcome. Today, we're diving into a really interesting breakthrough in blockchain privacy. We're going to break down how a new system on the Stellar network, called Pakana, is solving one of the trickiest problems in crypto: how to get private payments on-chain without stumbling into a massive regulatory trap.
Okay, so why does this even matter? Well, this quote from the Stellar Development Foundation really hits the nail on the head. You've got these huge players. We're talking Visa, Franklin Templeton, US Bank, all looking at public blockchains. But, they all run into the same exact problem: privacy.
And that leads us right into what you could call the public ledger's privacy paradox. See, blockchains like Stellar are built to be transparent. That's not a bug, it's a feature. But for a big financial institution, that kind of total transparency, well, it's a huge problem. So how on earth do you square that circle?
And here's that conflict, laid out plain and simple. On one side, you've got the public ledger. It's an open book, right? Every single transaction is out there for anyone to see. But then you have institutional finance, which absolutely depends on confidentiality. I mean, you can't have your competitors seeing your every move or risk exposing sensitive client data. These two things just don't mix.
So what was the first idea? Well, the most obvious solution people came up with is something called a shielded pool. The basic idea is pretty intuitive. You just create a kind of private mixing pot for money on the public blockchain, and you do it with some really, really clever math.
And that clever math, that's the zero-knowledge proof, or ZKP. Now, this stuff is basically like magic. It lets you prove that you have the right to spend some money without actually revealing who you are or where that money came from. And this is a big deal. Stellar's Protocol 25 update actually built the tools for these ZKPs right into the network, which made all of this possible.
On the surface, the whole process seems pretty straightforward. First, you publicly deposit your money into this one big shared smart contract. That's the pool. Then, you use a ZK proof to privately spend from that pool. And finally, the person you're paying uses their own ZK proof to pull the funds out. To anyone watching, money goes in, money comes out, but that on-chain link between you and them is completely broken. Problem solved, right? Well, not quite. And this is where things get tricky. We hit this hidden trap. Because even though a shielded pool seems to solve the privacy problem, it ends up creating a huge, and I mean huge, regulatory problem for whoever is running the thing.
This right here is the million-dollar question. The person or company that created the pool, the operator, they don't have the private keys. They can't steal the money. So you'd think they aren't a custodian, right? But for regulators, it's not that simple.
And the reason why is something called contract custody. See, from a legal and regulatory point of view, that smart contract itself, that big central pot holding everyone's funds, it's considered the custodian. And whoever deployed and operates that contract is ultimately responsible for it.
So here's the kicker. If you're a developer and you launch one of these shielded pools, you're not just putting some code out there. To a regulator, you might now be a money service business or a virtual asset service provider, and that means you are suddenly on the hook for some seriously intense anti-money laundering and know your customer laws. It's a legal nightmare that can completely kill a project before it even gets started.
But this is where the Pakana team had a real stroke of genius. They totally rethought the architecture to get around this whole contract custody problem. And they did it with one really elegant change. They separated the act of knowing about a transaction from the act of holding the money.
I mean, just look at the difference here. It's night and day. On the left, you've got that old shielded pool model. It's custodial, it's high risk. But on the right, you have Pakana's new approach. It's completely non-custodial. And the absolute key here is that the funds never get mixed together in some central contract controlled by an operator.
The big idea, the core innovation, is this concept of separating the signal from the settlement. Just think of it like two different tracks. The money, that's the settlement, it moves on one track. And all the private information about that money, the signal, it moves on a completely separate parallel track.
So let me walk you through how it works. First, the settlement. The sender moves the money directly, peer-to-peer, to a special one-time use stealth address that only the recipient can ever access. And this is so important. The funds never ever touch a central pool. Then comes the signal. The sender uses a totally separate smart contract to send a private, encrypted message, like a little note, to the recipient using a ZK proof. This note basically just says, "Hey, I sent you money, it's waiting for you at this secret address." The operator of the system only ever handles that private note, never the actual money.
And that architectural shift, that is what allows for true privacy by design. You get the confidentiality that institutions need, but you do it in a way that actually works within the complex world of financial regulations.
What this does is it completely redefines the role of the operator. They're no longer a financial intermediary or a money transmitter. No way. Instead, they just become a pure software or infrastructure provider. They're giving you the tools to manage your own funds privately, but you are always in control. And from a regulatory point of view, that is a much, much safer place to be.
So really, this new model is like a compliance checkmate. It's built for the real world. It fits right in with the Genius Act. Because, by never taking custody, the operator isn't a money transmitter. Simple. It works with UCC Article 12 because the legal control of the asset always stays directly with the users. And it's great for GDPR because it builds privacy in from the very beginning. It's clean, it's elegant, and it's compliant.
Which really leaves us with this one big final question. This whole idea of separating the information layer from the value layer, of separating who knows from where it goes. This isn't just some clever workaround for Stellar. It could very well be the blueprint for the future of compliant, institutional-grade privacy for all public blockchains.